Hey Math All Stars, it's Dr. Conklin. We are doing a review today for a quiz tomorrow on similarity. So make sure you have your similarity packet, and I'm going to bop around a little bit and do some questions. We already did example 3 on page 5, but I definitely want to do a question like example 4 on page 5, so if you could turn to that. And if we look back at the directions, it says, given triangle ABC is similar to DEF, what is the scaling factor needed to dilate ABC? So we're starting with ABC and we're going to EBF. So there's a couple ways to find the scale factor, but remember, when we have a similarity transformation, which that's what we're about to do, we always want to say it's a dilation about the origin and then find the scale factor. Okay, so what I'm going to do is find two sides that match up. AB matches up to DF. Man, this jazz music's too sleepy for me. Okay, so I'm going to line up AB and DF. Now we can notice the shape is getting bigger, so just be careful. If it's getting smaller, it'd be a fraction, but I'm going to take AB and see how many times it fits in, right? So if we look here, let's see how many there are in this flat edge. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So what is the ratio here? Well, if we said the ratio was 4 to 6, which is really 2/3, that would be making it smaller, but we want to make it bigger. So we're going to do 6 over 4, which really is 3/2 or 1.5 times as big. So our ratio here is going to be 3/2. Okay, so that's part of our transformation. So our similarity transformation, 1, we have a dilation about the origin by 3/2. And again, it was nice because we had that straight line to sort of follow. Now, how does one move to the other? Well, we can see here that it looks like it's flipping over the y-axis. And I'm just going to double check by counting from B to E, right? 1, 2, 3, and then 1, 2, 3. So our second step is going to be a little r, reflection about the x-axis. Okay? Are these rigid motions, my loves? No, this is not a rigid motion because the shape is preserved, but size is not preserved. Okay, that wasn't part of the question. I just added that in just because it's always a good idea to talk about rigid motions. Okay, so then I'm going to have you guys zoom down to page 6. So if you could flip over. And I don't want to do all of these, but just a few that wink wink might be like what you see on the quiz. So if you look here, we're going to first match up the sides that we have. So we have 14 and 35. Those sides we know match up. And we can check that by saying here BC matches up with EF. So I'm going to set that up as my scale factor, 14 over 35. Okay, now I'm going to put some variables in here. 10 should match up with this DE. I'm going to put an X in there because we don't know. And then I'm going to do the same thing here. AC should match up with DF. Okay, so now what we're going to do is actually set up some proportions here. Pick a different color. All right, I can't handle this jazz music. I'm sorry. I promised one of the kids, one of you guys, that I put jazz on, but enough. It's getting too sleepy for me. I'm going to have to change it. And you know who it's getting changed to. All right, we need a little halo in here, guys. All right, so 10 matches up with X. So I'm going to say 10 over X. And then to solve here, we're going to cross multiply. That's better. All right, so 35 times 10, divide both sides by 14. So then we're going to... And it's okay, I think we're going to get a decimal here. Maybe we won't, though. Oh no, we got 25. Okay, and then we're going to do this side here, 20 and y. So 14 over 35, again, the smaller. And then we're going to cross multiply. So 14y equals 20 times 35 is 700. Divide both sides by 14. So y equals 50. And again, do those answers make sense, guys? Absolutely, because if we look here, 10 to 25, 10 compared to 25, it's getting bigger, and then 20 to 50, right? Okay, we did one like number 2 in another problem. So let me see. I definitely want to skip that one. I want to do one like that. Okay, let's look at number 3, because this is one that shows up on the Regents a lot. And it's a little confusing because it's saying we have two similar triangles. Which of the sets of the lengths are possible given this information? There isn't really a great way to do this, guys, but just sort of go through and figure out the question. Now, I want to show you a trick, and I have to be honest, it doesn't always work. But on the SATs, if you start with the last one, that has a higher tendency to be the question that's correct. So if we start here, I'm going to label AB is 18, BC is 24, DE is 10, and DC is 16. So first thing we want to make sure, are these sides matching correctly? BC, does that match up with CD? Yep. And then AB, does that match up with ED? It does. So now let's cross multiply and see if those work. So again, we're just testing number 4. So I'm going to do 18 compared to 10. Does that equal 24 compared to 16? So we'll cross multiply here. Ooh, sorry guys. Okay, so 18 times 16 is 288. Does that equal 24 times 10? No, it doesn't. Boo. Okay, so the answer is not going to be this one. So it sort of stinks, but now we just have to go through. I'm going to keep those highlights on and see if choice 3 works. Okay, so now let's do the same thing. I'm going to put in 20 for A to B, DE 10, DC 7, BD. Now all of BD would be 14, which I'm actually just going to put in what if I know this whole thing B to D is 14, that means that this piece here would have to be 7, right? 7 plus 7 is 14. Is this possible though, guys, that we could have something doubled, right? This 10 should double to 20, but are these doubling, guys? No. So it's not going to be that choice. Okay, so let me again just start over. Sometimes we find on some of the Regents exams and other tests that actually the multiple choice questions take longer because you got to sort of go through. So B to C is 12, C to D is 8, A to C is 9, and C to E is 6. Okay, so let's set up a proportion here. So again, let's just make sure we know which sides are matching. So if I look here, oops, sorry guys, I meant to hit this one. AC matches with CE. Again, check up here. AC matches with CE. And then BC matches with CD. So now we can set up a proportion, just making sure, guys, that we're taking our time and we're comparing big to little. So 9 to 6, big to little, and 12 to 8. And then we can cross multiply, right? So 9 times 8 is 72. And then 6 times 7 is also 72. So that's the answer. Okay? And we don't even need to try the other one because we know that it's not going to work. Okay, let's look at number 4. And again, we want to make this as visual as possible for us. So if I look here, A to B is 12. Oops. B to D is 8, A to C is 18, and C to E is 12. What is a scale factor that would map A, B, C to A, D, E? So it's going to be a number that is greater than 1. We can only get a bigger shape by multiplying by something bigger than 1. So let me go through. Which one of these are not greater than 1? That's greater than 1, that's greater than 1, not greater than 1, not greater than 1. So before we've really done too much math, we already know that the number has to be bigger than 1, so we got rid of half the choices. So let's just compare one of these sides, guys. AB compares to AD. So 12, how do I find the length of all A to D? Well, I would add 12 and 8 and get 20. What does that simplify by? 3/5. Okay, now, do you see how that simplified to 3/5? Remember, we don't want the 3/5 because that would mean we have a shrinking or making the shape smaller. We want something that's the other way. So we just got to flip this, and that's our scale factor. Okay, we're definitely going to skip number 5. Okay, and then I want to look at number 6 and then call it a day. Okay, we have A, B, C. Again, remember this means similar to D, E, F. Describe a sequence of transformations that would map this guy to this guy. And you can use tracing paper. So I sort of already made a piece of tracing paper here. So there's a couple things we can do. First of all, we know that in order to get from one shape to the other, right, we would have to do some sort of dilation. So let's dilate about point A. And notice this isn't on a coordinate plane. So we sort of have to use the points we have. So what's the difference in these size shapes? So let me look here. And I'm going to move this guy over, oh, hold on. Before I do that, I got to go back one step, guys. Oh, sorry, my friends. Let me just make sure we have this. AB is here. AB matches with D to E. Okay, so let me just measure this out. And I'm going to circle it. Move it over. How many times does this fit in? Well, what's tricky about this is it's not like clearly 2 or 1. But what it is, it's a ratio. The smaller length of D to E, whatever that length is, over A to B. If I compared those ratios, that would give me the difference. Now, wink, wink, guys, we've mostly done them on coordinate planes, so that's what you're going to see on the quiz tomorrow. I didn't put one like this, but I do just want you guys to be aware of, if they don't give it to us on a coordinate plane, how we could also do this. And then how did these sides line up? D, E, well, the only way they work is by a rotation. So we would have to rotate about A so that DE okay, so the last one for number, well, actually, hold on. Okay, the last one for number 7, guys. It says in diagram below, DEF after annihilation with a scale factor of 1/2. So I think that's one of the things we wanted to just cover with you guys, because we noticed that some people were getting a little confused about when we have 1/2 versus when we have 2. So DEF is the image of ABC. That means this came first, this came second. So here's first, here's second. If you do not have a straight line to count, what you can do is I'm going to highlight the smaller one. Now you could use a piece of paper and you could sort of line it up to see how many this is. And then you want to see how many of these fit in. So 1, 2. So that means that 2 of EFs fit in. So since we're going big to small, our ratio, or our K value, is going to be 1/2. This is if we're shrinking our shape. If we were going the other way, it would be the opposite. Okay? So I just wanted to look at that picture make sure you look and see if the shape is getting bigger or smaller. If it's getting smaller, you should be doing a dilation or a dilation about the origin of some sort of fraction number. If it's a dilation where it's getting bigger, it should be a number, like a whole number, a number bigger than 1. So 3/2, 2, 4, whatever works for you. Okay, so let us know if you guys have questions. Keep up the great work. I hope that review helped, and we will talk to you guys tomorrow. Bye.